Hi, we're live from Basin Safety Consulting and Training Studio here in Williston, North Dakota. This month we're going to be covering fire extinguisher use, safety, and handling. My name is John Greiner and I'll be your presenter this month. Thank you very much for joining us May 2020, and we're going to go ahead and get started with the presentation. So today's agenda, we're going to go over a few basic things about fire extinguishers. We're sure you've probably used one or had some experience using one in the past. We're going to be covering elements and classes of fires. We're going to be covering hot work permits, fire watch. We have a short video included for hot work and welding purposes. We're also going to be talking about fire extinguisher tips and what to do in the case of an emergency. So each of these elements must be present during a fire in order for the fire to first of all start and then continue. So they used to call this the fire triangle, but then about 15 years ago they updated it to be called the fire tetrahedron, which essentially just is a triangle but three-dimensional. And the element they added was chain reaction or chemical chain reaction. And essentially what it's saying is for a fire to exist and continue, it needs to have some sort of reaction happening. And certain extinguishers are really come in between that whatever it is that's burning and the flame and stops that chemical chain reaction. So anything, whether it's gasoline, table, wood, paper, plastic, etc. The item itself does not burn. Nate, I have Nate in the studio here as well. You can't see him, but he's kind of our audience. Nate, it doesn't necessarily burn itself. What happens is it releases a gas as the temperature around it heats up or increases. So as that temperature increases, the fumes that it gives off, whatever material it is, gasoline, diesel, as I mentioned, paper, plastic, etc., they heat up and they ignite, and then it continues to release those vapors, which is the chemical chain reaction. So once again, anytime we can stop that, we're good. Then you also have the heat, the fuel source, the material itself, and oxygen, also a necessary component to any fire. So if you can remove oxygen, heat, the fuel source, or stop the chain reaction, then you're going to eliminate the fire. So there are 5 classes of fire. You have class A, B, C, D, and then of course K, which a lot of us aren't really using in the oil and gas industry, but we'll cover that briefly. So class A extinguishers, or class A fires, A extinguishers are for A fires, are typically anything that we say turns to ash. So that's kind of the quick acronym for that. So paper is in that category, wood, some plastics would not be in that category, a lot of debris, trash, etc., all going to be in the class A fire. Class B fires are anything that have a boiling point. So typically gasoline is going to be in that, diesel fuel, any liquid chemical that has a boiling point. So I'm not saying you try this, but if I were to fill my coffee mug here with gasoline, put it on the range, it would start to boil. Now it'd probably explode as well with enough oxygen and heat, so we're not going to try that. I'm probably just going to keep coffee in this mug. Class C is anything that has a charge or has current moving through it. So those are your electrical fires. So we've all probably smelled this, especially if you grew up in a house like I did. It was built in the 30s, 40s, 50s, does not have grounded outlets. Typically those wires would heat up and you'd smell that acrid burning rubber smell. That any fire that's started by electricity is considered a class C fire. Class D, once again, not something we typically are going to see in the oil and gas industry, but those are metal fires or anything that dents. So this is an easy way to remember that. So magnesium, sodium, these elements of nature that dent a metal typically, they're going to ignite, and that's considered a class D fire. Class K fires, as I mentioned, not typically oil and gas. That's our kitchen fires. So class K equals kitchen. That's the only one that they did that for us, fortunately. But the rest of them, you kind of have to remember that acronym. Most extinguishers we're going to see out here are A, B, and C fires. So I'm going to go ahead and skip over a couple of these. But in Class B, it's important to note that how you transfer fluids will have an indicator of whether or not there's going to be a fire. So if you use, for example, a diesel pump or a diesel fuel transfer system for gasoline, that diesel transfer system is rated for a certain temperature and can spark just a little bit actually. So when you put gasoline in there, it's not rated for that purpose and it will absolutely ignite. There's other things that are going to cause Class B fires to start, typically storing them around unlike chemicals or potentially combustibly volatile chemicals next to each other, and obviously open flames, cigarettes, static electricity, which is a big issue in North Dakota when we don't have a lot of moisture in the air. So right now, probably near the end of winter, you notice a lot more static electricity, and that's why. Class C. So a lot of things can start Class C fires. Some of the major issues that we deal with in the Class C world are, as I mentioned, electrical cords being plugged into outlets that are not designed for the amperage that it's pulling or the voltage that it's pulling, or the cord itself not necessarily being optimized. And what I mean by optimized is essentially when you have let's say a power outlet, like a strip, and you plug an extension cord into this. And a lot of guys do this, Nate. I don't know if you see it very commonly out there, but they'll plug an extension cord into a power outlet and then run it. The problem with that is typically the gauge on those extension cords is larger than the gauge that's in the the outlet itself, the strip outlets. So what's gonna happen is the power from your source, typically your wall, the receptacle, is gonna deliver power to the extent that power strip is requiring it. And then it's gonna jump to the extension cord. And when the gauge and the voltage amperage that is drawing is higher than the power strip, it's going to heat up. The power strip's going to heat up. Now, there are certain systems that are designed to essentially trip that breaker if that occurs, but not all of them are, especially if that system receives a cut. So what'll happen with GFCIs, and we'll get into this in a little bit, but ground fault circuit interrupters are designed as essentially a circuit reading device. So as that power moves through the circuit, it's determining that as much amperage as it put out, it's receiving back. And if there's any release in that, for example, water gets in it, or there's a cut to the cord and it's releasing something into a system that's not returning it back to the indicator or the meter, then it's going to trip on you. Circuit breakers are designed to measure too much amperage being pulled more than what it's designed for, and that will also trip a breaker. But if those systems, if there's things that happen to those that don't change the amperage initially or change the amount of voltage being pulled, then they are going to cause a fire. So for that reason, you always want to make sure you follow the fire marshal's recommendations for power strips and other power cords, as well as ensuring that you're using the right type of power cords and systems during construction. Class D, as I mentioned, metals, magnesium, sodium, etc. Some of these water, Class A extinguishers, for example, will actually become a fuel source because it separates the hydrogen from the oxygen and uses both as a fuel source. So ensuring that you have the correct type of extinguisher for the correct type of fire is absolutely vital. And the only way to really know that is to read your SDS for that chemical or material before you go about putting out a fire. So typically that should be a part of the training in your company. If you have certain chemicals back there in the corner, you don't know what they are or what they're for, not a bad idea to find out, especially if you're responsible for any firefighting duties or any safety duties in your company. So Class K, as I mentioned, not our day-to-day, but that's for kitchen fires. So typically for fats and grease, when they catch on fire, the challenge with those two fuel sources is as you put them out, they can stay dormantly ignited and reignite after a time. So ensuring that it's actually perfectly out, and Ks are typically a wet chemical that essentially cools that material as well as preventing reignition. So the next thing we're going to talk about is hot work permits. Now, hot work is typically done on well sites, and when that occurs, there's a few questions that you have to ask yourself. Am I welding, operating a vehicle, a piece of equipment, a drill, a hand power tool of any kind, within 35 feet of a potential ignition source? So you have the storage tanks, you have the treater, you have the wellhead itself, you even have the flare where there's combustible gases either being mixed, stored, or transferred. And in those instances, before you do any work with any heat element, you need to have a permit to ensure that those combustible gases are not in your current work area. So here is essentially the requirement set forth by OSHA and ANSI. All combustibles shall be relocated at least 35 feet horizontally from the work site. Now, if you're above that area, there may be different requirements depending on the type fuel source that you're working with, or if you're below, same difference. There may be some extenuating circumstances, and then you have to look at that specific type of material and the SDS once again, or accompanying materials about that chemical. If relocation is impractical, or if you can't do that hot work somewhere else and then bring the welded material or grinded material back to the well site, combustibles will be protected with fire retardant covers or otherwise shielded with metal, fire retardant curtains, blinds, etc. And then also you're going to want to have a fire watch in those instances. So as we mentioned, most operators do require hot work permits before you do hot work at their site. If you don't have a hot work permit, what will occur is you're essentially violating the standard and potentially putting yourself and other people at risk. So I mentioned welding, any sort of burning, brazing, if you're grinding, cutting, and even operating a vehicle in some instances near a wellhead or other source, then you're going to need to complete one of these. So I screenshot an example of a hot work permit that we have at Basin that we use. Very simple. Ask some direct questions about the type of work that you're performing. So here I zoomed in a little bit on some of the instructions and questions. So this permit authorizing individual must first verify precautions are essentially managed or mitigated. Also complete and retain this page for a period of time. Usually it's about 3 years that you have to keep this. So what we do, we'll do the hot work permit, we send it electronically, and then we keep that with the work ticket for the work that we did that day along with the JSA. So obviously the basics: date, location where you're performing work, what type of work you're performing, and then what materials that you're working around that could be potentially flammable or combustible. So you want to take a 35-foot spherical essentially map of the area that you're working in, and right at the center of that it's going to be where your hot work's being performed. You're going to take your 35-foot circumference, say, am I working in this area? Yes, I am. And then there's some additional precautions to follow. So essentially, we want to make sure that sparks are either maintained right where the work area is or dampened so that they don't reach areas of combustible gases. Then also work on walls, ceilings, fire watch hot work areas. You have different requirements based on the type of work you're doing. So in this case, it's pretty much a check mark. And then at the bottom of the page, which I didn't screenshot in, it has your air monitoring record. While doing hot work, and we'll watch a video a little bit later, a short video that talks about the dangers of performing gas detection and analysis improperly or not at all, and what some of the ramifications of that can be. So fire watch, many of you are probably familiar with this. Essentially, a fire watch is a duty of an individual to watch that work site a minimum of 30 minutes after the work's being performed, as well as while the work is being performed. And their job is, even though you've put in the engineering controls of blankets, whether welding blankets or spark shields, walls, barriers, etc., that nothing escapes their eye and then catches something on fire. So our goal is that even after you leave a work site, just think of the old Smokey the Bear adage. You want to put the fire out and then wait for 30 minutes after you put the fire out before you leave, just to make sure that it actually was put out. So they have to have extinguishing equipment at the ready, obviously, because you want to make sure that that individual is ready to extinguish that fire. Now, the extinguishing media, depending on what you're doing, doesn't have to be fancy or sophisticated by any means. For example, during welding operations, I don't know if you know this, Nate, they actually allow you to use a cup of water for fire watch duty. So you don't have to have an expensive extinguisher you're deploying, because we know there's going to be fire when you're welding. There's going to be sparks. Depending on where you're at, they may blow around if you're outside. So in that instance, you can just use a cup of water or essentially a water hose, anything that's actually going to effectively extinguish that media. And welding, sparks, and slag are considered a Class A fire. So how is a fire watch conducted? That's a great question, Nathan. Thank you for asking. Fire watch consists of one or more qualified persons performing fire watch duties. And these are the functions that are involved as well. Diligent watch for the fires, as I mentioned, preventing ignition sources, so knowing where they're at, ensuring that they're capped, blinded, ventilated off properly, depending on what the scenario is, ensuring adequate means of egress for whoever's doing the work. So if my fire watch is watching, he needs to make sure that nothing's encroaching on my way out if something goes wrong. Promptly remediating hazards that are found, being prepared to contact the fire department. In a lot of cases, what I recommend is having the fire department, if it's a big job, having the fire department at the ready and just saying, hey, We're doing a lot of hot work over here. Here are the hazards. We just want to let you know that so that if we call, they're not scrambling to get everybody to the fire department in an instant. Being ready to extinguish any fires using the portable fire extinguisher or media of their choice, and also warning the occupants of any hazards. So really, a lot of guys, what they'll do is they'll say, we need a fire watch. Who's the, you can do a fire watch. You're a warm body. Well, I want to warn you of that a little bit. Not a bad idea to put a newer guy or somebody who's kind of coming up in the world as a fire watch. However, without the proper fire watch training, you really probably wouldn't trust that individual to adequately assess the hazards and inform everybody of those hazards and know what to do in the event of an emergency. And so for that reason, I highly recommend, if you are using fire watches, to ensure that they have the proper training. It's not a 15-day course. It's not even a 40-hour course. Typically, it's 2 to 4 hours to get someone, fire watch trained or certified. And it's candidly a lot of common sense in that. So some PPE that individual is going to have absolutely at the ready or on themselves. FR clothing, gloves that are, FR rated. Typically leather is going to be in that category. Safety glasses, hard hats, safety-toed boots, respiratory equipment should be available. And obviously, when you're dealing with fire, smoke is a possibility. So having respiratory equipment available makes a lot of sense if that's the individual required to ensure that that fire goes out. Then lastly, proper fire extinguishers, whatever those are. Now that wouldn't necessarily be understanding fire, but that's one of the things that we need. So I'm going to go ahead and skip past this video. It's a little bit short, and I think we can skip past it. So fire extinguishers, there's different types. We already talked about them. You will be seeing a video here shortly, the one I mentioned, where we're actually going to walk you through how we do a fire extinguisher research so you can see the process and what's all involved in that. So we have water extinguishers, I've already mentioned, foam, carbon dioxide, powder, and wet chemical. All these different types of extinguishers have a different purpose, and they eliminate one of those fire tetrahedron elements. So fuel, heat, oxygen, or chemical reaction. And that's what they do. That's their job. So water extinguishers, essentially, as we mentioned, they're typically going to cool the fire down. So if it's a piece of wood that's on fire, you wet it down with water, it cools it down. Therefore, that heat necessary for the fire to occur no longer is there, as well as preventing the chemical reaction. CO2, essentially these are typically good for electrical fires, and what it does is it leaves behind a harmful residue, but that residue prevents that the cord or the housing of that cord, the rubber, whatever material they're using, from igniting. That's essentially the residue prevents that chemical reaction from happening. Wet chemical extinguishes fires and designed specifically used with combustible cooking. As I mentioned, it essentially soaks up whatever grease and fats that are there and prevents them from reigniting. Foam typically is going to remove the oxygen from the fire and then also prevent reignition. Those are both A and B. And then powder, which is once again an A, B, and C fire extinguisher medium. That's the kind that we're going to show you how to refill today. They kind of both prevent the chemical reaction from happening as well as preventing the oxygen from being a part of the chain reaction. I want to talk about NFPA symbols very quickly. You'll see these around. This one is actually for hydrogen sulfide. Crude oil. And so each of these diamonds have a different symbol, meaning, and purpose. So the one on the left is red, and that's for flammability or combustibility. The higher that number is, the more flammable. The lower that number is, the less flammable. And what we mean by flammable is flash point. Flash point is the least temperature, the least degree of temperature necessary for that material to combust. So for example, gasoline, I believe, is -30. So what that means is at -30, that material is still at a proper temperature to ignite. Other chemicals are going to be much lower or much higher depending. And excuse me, I said the left, but that's actually the top. The left diamond is health, and that's the blue color. And once again, that's lower being less severe, less dangerous, higher being more severe, more dangerous. The white at the bottom typically is where you're going to see like a W with a line through it, means don't use water. You're going to see corrosive, or COR for corrosive core. And then on the right, it's reactivity. And this is typically dealing with things such as radiation, etc. So that means does it react with the environment, being shaken, etc. Are there elements of this that will cause a reactive nature? So I want to get into the oil field here a little bit because, once again, that's our industry. And I'm going to show you some things that most of us see on the day-to-day basis. So here is a Stepis flare stack. This is essentially a flare stack that's designed to consistently work without using typically they use just a spark plug at the end of a cord, and it's constantly giving it power so that it sparks and sparks and sparks. So whenever gas comes through the flare, it's going to ignite. This is essentially an engineered or smart flare, and it not only is going to ensure that that flare stays lit, it's also measuring the cubic feet per minute that are flowing through that flare to determine how much gas is being burnt off. So those are pretty good systems. This is an area within that we would require a hot work permit if the system was going to stay live. If you're shutting the well in, then that may change things, but once again, consult the operator and their requirements. They still may require a hot work permit. Inside of a treater and outside of a treater, I've got two pictures here. The one on the left is a horizontal and the one on the right is a vertical. So inside the horizontal treater, you see a lot of different openings here. You have an oil sample point, you have a scrubber pot where you can get samples, and the top of that scrubber pot is typically where we insert methanol to make sure that it doesn't freeze in the winter, because typically these don't have any heat in them aside from what the treater itself is being lit at. Now, if you look to the right, the picture on the right, that is a vertical treater, but the flare, or excuse me, the burner in there in the fire tube, essentially we have to light those in order for the treater to stay at a certain temperature. And then there's knobs and gauges in there that you can change the temperature on. So depending on how much air you're letting in, etc. So inside of those, you have natural gas being burnt off intentionally to heat the separator or the treater, depending on what it's attached to. And so the stack there is obviously alleviating that heat, and the smoke and the vapors are coming out of that. So on the back end of these systems, you have a fire tube and a burner, and on the front end, you have highly volatile crude and natural gas being stored and transported through the system. So that is one of those dangerous areas where we don't want any additional hot work going on within a specific distance, once again 35 feet of that system, because of the volatile nature of what we're working with. Everything in oil and gas is flammable that we're dealing with. So ensuring that sparks, obviously cigarettes and other heat elements, that we're keeping those as far away from potential danger and ignition as possible. So this is an outside horizontal treater with a burner and the tube there. So essentially, and I put that this will be hot there because you don't just want to go up to something and be like, this is hot, let's spray it with the fire extinguisher. No, it's designed to be hot because it's, once again, alleviating the vapors. On the right here, we have a wellhead, and this one happens to be hooked up to an ESP. This is another area where you may experience rogue gases. So if you're doing work around any of those, as well as the tank battery, you want to ensure that you're 35 feet away and you're doing continuous air monitoring. So hot work people must be trained, people performing hot work tasks and duties, as well as anybody else performing hot work on the site in the hot work safety training. And it's not a bad idea, as well, as I mentioned, to know the chemicals in your workplace. That kind of follows the globally harmonized system, which is a topic for another time, as well as what sort of things do we do together in tandem that could potentially work together to cause a fire, or cause an explosion, or cause some combustible material to be ignited. Now, inspecting fire extinguisher systems, every type of extinguisher has a little bit of a different recertification expiration date, but typically you're going to see 1 year, 6 years, and 5 years. So in the 1 year, that's where essentially they need to be inspected every month, but that's more of a visual inspection. You can tip it upside down, tilt one. Nathan, if you want to grab me that extinguisher over there, I'll just go ahead and show that really quick. That's a pretty basic monthly inspection. I'll perform one with you right here, and you guys can do this. I'll give you credit for it. You can do this at your shop if you're paying attention. The 1 years and the 5 years or 6 years, those are a little bit more in depth, and we're going to show you some more of that in a bit. So this is your typical 5-pound ABC extinguisher. You can see it listed right there. It should have the month and date that it was recertified, and it should be within the last calendar year. So right here we have March of 2020. So this one was done just a couple months ago. This is Basin Safety that did it. They also need to have information about the fire extinguisher number, as well as their certification number for being able to perform these services. Other elements of a fire extinguisher, you're going to have your hose. This should be tight. This one, they can loosen very, very easily. They're designed to be able to come apart very quickly. But you want to make sure that this is tight when it's on the wall or in the back of your truck. Now, obviously, vibration, if it was that easy to loosen it, can, and a little bit more difficult to put it on apparently, that can go ahead and wiggle this loose. So I'm just going to go ahead and leave that off right now, unless I can get it. Oh, there we go, I got it. So, yep, those are pretty easy threads to loosen, so you want to make sure that's nice and tight. Some other things you'll check during your monthly check is obviously you want to sign it off when you're done. You're going to check the handle. You're going to give that a squeeze and make sure this pin is, one, in there, and two, that it is not going to come out easily. So in this system, we actually have a pin keeper, which is nice. That's a new element that they've added in the last few years, but these can break and be removed very easily. You also have another pin keeper. This one's designed to keep it in place. This one's designed to keep it from falling away from the extinguisher. Both of these, over the course of a year or two, can be brittle, especially if left outside. So if you don't see these, that's okay. You can pick them up pretty much anywhere, and we have them here at the shop as well. The other thing you're going to check for is right here to make sure that it's full. You have our pressure gauge, and then also you're going to check for corrosion, cracking, and wears around the neck of the extinguisher. So go ahead and give it a good turn. You want to look up underneath it, make sure that there's no swelling, there's no breaking, corrosion, etc. And the other thing you want to do every month is you want to go ahead and turn it upside down. I don't have a rubber mallet with me, however our guys do carry these when they inspect them, and then you'll just go ahead and give it a couple taps right there on the bottom. When they fill these, they fill it first with powder and then they pressurize it with air. So what you have is a bunch of powder that's in the bottom of the extinguisher. If it's not turned upside down and knocked every once in a while, that powder will actually harden and cake in the bottom, and when you go to use the extinguisher, nothing's going to come out except for the air that's pressurized on top of that powder medium. So our job is to essentially make sure that that powder gets broken up and does not cake and harden in the bottom of that extinguisher. So when fighting a fire, there's a basic acronym. A lot of you probably heard it in the past. It is PASS, which stands for pull, aim, squeeze, and sweep. So I'm going to go ahead and pull this one just to kind of give you an idea of how easy it should be. Just go ahead and pull that. You feel both those pop off there, or at least the one. Then you're going to aim. Then you're going to squeeze. Now I'm not going to squeeze because Nathan would be engulfed in ABC powder, and I don't think he'd be working here for very long after that. Although that would be a pretty funny prank if we could get that on video. I don't think safety companies should engage in that behavior, but it would be pretty awesome. A guy can have an imagination. So then you squeeze it, and you're going to aim at the base of the flame and sweep from side to side. So pull, aim, squeeze, sweep. The reason we're shooting at the base of the flame is because that's where the chemical reaction is happening. So we want to ensure that whatever it is that the fuel source is, that it cannot continue to release vapors that are being ignited by the flame, because the flame's at a certain temperature, obviously hot enough to ignite the medium or the fuel that's being lit. Nate's coming over here under the table. It's kind of creeping me out. Thanks for cleaning that up, Nate. We appreciate it. So 10 tips on how and when to use a fire extinguisher. Obviously not at Nate for fun, even though that may seem like a good idea at the time. Most fires do start small, and that's typically when this is most useful. This bad boy is going to give you about 5 to 15 seconds. I wouldn't give it over 10. And so if you can't put it out in 10 seconds of removing the fuel source, or stopping that chemical reaction, if it's not big enough to do that within 10 seconds, then you're probably going to want to abandon that op and go do something else. Typically run away in the opposite direction through your posted exit sign. A fire extinguisher should be listed and located. Essentially, it needs to be tested by, they call it Uncle Louie. So I'm going to go ahead and turn this until we see it. So the Uncle Louie, that's essentially listed. It means that we know that it works, right? We can't buy these off the boat from China at a 50% discount if they're not Uncle Louie tested. So before attempting to fight that fire, also you want to make sure people are out of the area and your egress is secure, meaning you have a direct path away from that fire, so that if it fails, doesn't work, that you're not going to be caught in the flames. Also, using the extinguisher quickly requires some hands-on training. Obviously, pretty easy to pull the pin. Actually, fighting that fire is a different thing entirely. It takes a little bit of experience and practice to know how a fire works, because you are actually fighting that fire and it is fighting you. It wants to continue burning, and our job is to essentially eliminate that possibility from occurring. So if you haven't done this before, if it's small enough and you can get inside of a trash can or something, pretty easy. They also have fire blankets for that purpose. You can put it out. But if you're actually fighting a fire, especially a combustible chemical or fluid, even a metal, you definitely want to make sure you get some actual hands-on training. So we already kind of went pull, aim, squeeze, and sweep, talked about those a little bit. And I really like this one. If you have any doubt about the safety of you performing fire extinguishing activities, do not do it. An average well site, and I showed you some pictures there's some extremely expensive equipment on a well site. I mean, typically the facilities, anywhere from $2 to $3 million. However, the average fatality in the oil and gas industry is about 4.5. So even if you don't care about your own life or other human lives, and you're more just a financially driven person, you should know that there's really no value in fighting that fire from a life and risk safety. All that stuff's insured. It will be replaced. You cannot be replaced. So even if you don't value yourself economically, it's still a better thing to just go ahead and let it burn. So lastly, your safety does come first. Can't stress that enough. Always make sure you have a quick path to egress, and it's in the small insipid stage. Excuse me. So the treater being on fire, Nathan, I don't know, they'll probably be able to hear you if you talk loud enough. If the treater is on fire, would this extinguisher be able to put it out?
No.
What about a 10 pound?
No.
20 pound?
No.
Not going to work. 30 pound?
No.
Wheeled fire extinguisher?
A wheeled fire extinguisher?
The really large ones?
Oh, maybe.
Maybe. And that's a maybe. And the thing weighs about 150 pounds. So if you happen to be in an area with a 150 pound extinguisher and just see a fire starting in a treater, maybe you'll have some impact. But once again, that has to do with whether or not you isolate the gas stream or the oil stream. So if you can't safely do that and extinguish the fire at the same time, that's an abandoned ship moment. That's time to get out, because the amount of pressure, the amount of fluid, and the amount of volatility in that system is astronomical. Your job is to get upwind and crosswind as soon as possible away from the area. If a wellhead's on fire, same thing. We're talking next level type of carnage that would occur. Tank battery, same game. Now the recycle pump, the burner side of a system, those can ignite, especially if it gets a little bit of liquid gas in there. In those instances, definitely want to use your common sense and the level of training that you've received. But typically in those instances, everybody wants to get out. So as we mentioned, we're going to talk a little about emergency. So every fire is an emergency, even if it's a small one. We're in emergency mode here. So earlier we talked about getting everyone out of the area, and that is priority number one. First thing you want to do is communicate to everybody to leave. So if you can't do that before starting the extinguisher of the fire, then it's probably time to leave the fire and let everybody know. Because if you begin to try to put out a fire and it gets out of hand, it can get out of hand very quickly and trap people. So we want to make sure everybody gets out as soon as possible. Another part of that is being prepared by use of drills. So have you done a drill in the recent times? And if not, volunteer. Say, hey, you know what? I think we should do a drill here. I'll go ahead and be in charge. You don't want to do a drill in the middle of a serious operation or something that's taking a lot of time and resources. But definitely when you have everyone together during a JSA meeting, a safety meeting, it's a good time to go ahead and practice a drill without expending a lot of resources in order to do that. Now you can do it during a serious operation as well, just to ensure that even in the most serious and the most intense moments that people have the experience necessary to safely get everyone out. And at that time, you'll also want to do a head count after you arrive at the muster point. So knowing your evacuation plan, where the muster point is obviously important. Knowing where the alarms are, nearest exits are located at all times. When I go to a hotel, and I'm probably weird this way, I like to know where that door is to go downstairs, the fire exit door, because you can't use the elevator. So I typically will count how many doors down I am, so that worst case scenario, if I have to get there, I can feel my way along and say, okay, I'm 12 doors, and then it's the 13th door on the left. Because when a hallway is filled with smoke, you're not seeing that little exit sign, I promise you. Like you're supposed to be able to kind of see the glow. Depends on how much smoke. Because if there's a lot of smoke, you're not seeing that glow. And they also have other lighting and things that may be kicked on, which would obscure your ability to see that. So knowing specifically where you're at and how to get out and what's obstructing you is vital. Also making sure nothing blocks you from getting out as far as the fire path goes. So if you turn around and see a bunch of plastic gas cans, once again, this is the reason they're outlawed in OSHA, in oil and gas industry, is they are a potential ignition source or continued fuel source for a fire. If you see those between you and the exit, you do not want to do anything about that fire. You want to get out, and preferably out and around those gas cans as you go. So making sure that the exit routes are clear is obviously super important. Definitely not, littered with potentially combustible or flammable liquids. If you have a building alarm, knowing that sound, if you're on a well site, they typically are going to have some sort of emergency system where they say 3 long horn beeps. Maybe they'll use the rig horn or some other horn to alert everybody that there's a need or there's an emergency. And then also posting emergency numbers so people know who to call immediately. And obviously 911 is a great bet, but that may not be the most or only phone number to call to quickly get somebody out there to put out the fire. For example, if you lose well control and the well catches on fire, 911's doing nothing for you. They're going to watch it burn like everyone else. You'd need a specialized group of people such as boots and coots, wild well control, to actually come in and isolate the oil and gas and then put the fire out. And then lastly, making sure you know what to do when the fire alarm sounds, planning your escape. Typically, what I like to encourage every company to have is an individual who's responsible for this purpose, who's typically somebody who's around, not only for sounding the alarm, but contacting the authorities or directing the contact of the authorities and ensuring everybody gets to the muster point is accounted for when there's a fire. So kind of reviewing here, I'm gonna let you review this slide. I just want to thank you for being a part of our training this month. Hopefully in June, most of us will get back to face-to-face meetings. If you're a continued online subscriber, please let us know if you like this platform. Typically, it's just kind of the read over, but I figured, hey, these guys haven't seen my face yet, and I can't help myself. I need to get it out there. No, we want to kind of make these as interactive as possible. So next month we'll probably have a guest in our training. So we're excited about that. We're going to be doing first aid as well as heat safety awareness. So be looking forward to that, and see you next month.
The pressure is going down because the powder is going from in here through that tube into that hopper because there's nitrogen inside. Pressurized nitrogen.
Official sound there.
Yep. While that is happening, I will Now we have an empty fire extinguisher. And what you're gonna wanna do is take it over to this press. Find the correct length. And just turn this switch on. And then you can remove it, the handle.
Out of the way.
Gosh. Okay. And then when you're taking this out, you have a cloth. You just want to take and put a cloth around it so that the powder doesn't get everywhere when you're taking it out. And then you have to disassemble the straw from the handle. If it's too tight, you'll probably need a crescent.
Octavia and then click it.
There you go, crescent. Once that is done, you're going to want to clean everything. Oops.
There's another one on the table there.
There we go. This can be done with a wire brush. So that's a spring. You're going to want to remove the valve stem from inside. One way to do that is to take the punch. If I can find the punch. Where's the punch? There we go, the punch. And take that and bop that. There. There's your valve stem. You're going to want to clean that off. After that part is clean, then you're going to want to clean the inside. The next step is to apply lube to all the rubber. And then when that is done, you can put it back inside and reassemble the handle. You want to put your spring, the small side of the spring goes in first. And once your straw is clean, you can reassemble the straw to the neck of the handle. Alright, and then you're going to want to clean the O-ring. And then apply lube to the O-ring. Once the lube is evenly applied to the O-ring, you can reassemble. 26 pounds. Now we're going to fill it up. here.
Yeah,
This is a good one. Okay. After the canister is filled to the specified recharge amount, you have to put this tamper seal on and then reinsert the refurbished handle. And try not to cross thread. After that's completed, you can bring it back to the vise. And then you can hand tighten it. Then after that's completed, it's time to refill it with nitrogen. So you're going to want to put this nozzle back on. This nozzle will convert it to nitrogen. Before you fill this with nitrogen, you're going to want to shake the powder. Now we'll fill it with nitrogen. Wait for a couple seconds to make sure that the pressure is equalized. Once you're satisfied, you can disconnect the nitrogen. First thing to do is to put a brand new pin in. Then you can remove the nozzle. And you can put a fresh tamper seal through the pin. And then you can tuck the excess behind the gauge. After that's completed, then you just have to put on the tags. So this is the annual inspection tag. Just check the boxes. This is an ABC fire extinguisher. Dry chemical. It does have pressure. And then just write the date. And that will be good for 1 year. Then enter the serial number onto the first line. 1026. And then write the name for who it was serviced by. It was serviced by me. And you will need to have completed your NFPA 10 to be able to do this inspection. And after that, you'll make your 6-year tag. You just have to punch out the date. May the 4th, 2020. And then you're going to want to initial. Then you're going to want to clean the hose before you put it back on. You can reset disassemble. The last step is to put a metal inspection tag. Cut the excess. And then you can do the first month's monthly inspection. Just initial. You can also hole punch it. Either will do. And that is your 6-year service.